In this lesson, we're going to examine the nature of roots. That is, the idea of whether a quadratic can be solved or not. There are three different kinds of situations we need to examine. A quadratic could have two roots, two solutions, two zeros. Those are all interchangeable words. If it crosses twice. It could have one root where the vertex is your zero, or it could have no intercepts. We don't cross the x-axis at all. So it has no zeros. In other words, it has no solutions. We kind of like that situation where we have no solutions because that might mean that this problem can't be solved. It's just as important as is a solution to a problem. Depending on what format of an equation you're given, vertex form, standard form, factored form, you can identify the number of roots or x-intercepts pretty quickly. The best way is factored form. If you have an equation that's in factored form, the fact that you can actually factor it, factored form, means you have to have roots. The only question is, are they the same or are they different? So they'd be the same, for example, if you saw x minus 1 and x minus 1. The same thing twice. That's one root, 1, 0. Or maybe you have two different roots. I got two different numbers here. That means I've got two different solutions. That's pretty easy to identify. You can look right at the equation. No math required. The next easiest type is by looking at vertex form. Because in vertex form, we can easily sketch a diagram based on our vertex and our direction of opening. Looking at your picture, you can then tell how many roots you have, how many zeros. So we try the first example here. Our vertex is 3, 4, and it opens up. Well, a real quick sketch of that, 3, 4 opening up, tells me really quickly I never cross the x-axis. I've got no zeros. And I don't need anything fancier than that. If we look at the next one, our vertex is -2 and 0. There's nothing out here, right? No k value. It opens down, so negative. Well, -2, 0 is right on the x-axis, which means I have 1, 0. The third one, our vertex is -5 and 3. I know it opens down. And if I draw that real quick, down, oh, I got 2 zeros. Okay. A really quick sketch, really quick information tells us how many zeros we have. Our objective today isn't to figure out what the zeros are. That would be solving. Our objective today is just, can I solve? And what does those solutions or lack of solutions mean? Now the messy one, standard form. I hope you recall something from grade 10 called the discriminant. The discriminant is the part of the quadratic formula underneath the root sign. So if you think about that, all I need to do is figure out whether this piece can be solved. So if I know if that can be solved, then I have to have roots. So here's a couple rules you might remember. If this number underneath the root sign, our discriminant, is positive, it's greater than 0, then you have two roots. So plus and minus come into effect. If, however, that number is a 0, then this won't matter because you have 0. This won't matter because you have 0. And all you're left with is this number, which tells you have one root. And if you get a number underneath the root sign that's a negative, well, you can't square root a negative. So you have no roots. Okay, so we're using that piece of the quadratic formula. Let's try a couple. The only trick is make sure they're in standard form and equal to 0, right? So my discriminant, a, b, c. I need to do b squared minus 4 times a times c. Plug that into our calculator. Now I don't really care what the number is. I only really care about the sign, but we might as well do our math correctly. I get -32 when I do that. And what does a negative tell me? I can't square root negatives, so no zeros, or no roots in this case. That's what they asked us for, roots. Try the next one. Our discriminant, 6 squared minus 4 times a, be careful with your signs, c. plug all that in and I get the number 0. Well, the square root of 0 is 0, which means I can calculate it, but it doesn't get me much. So I've got 1 root. And then the last one, b squared minus 4 times a times c. Now c is over here. There is no number there, which means it's a 0. So I end up with 49. It's a positive, so I got 2 roots. I have to worry about that plus minus sign in front of the root sign if I actually calculated them. So those are our 3 forms. We want to be able to identify real quick which form we have, how I can figure out how many roots it has, and then how can I use that. So a little problem solving for us. I want to know whether the vertex of this parabola lies above, below, or on the x-axis. Now I could do that if I had vertex form really easily. I could draw a picture, but I don't have vertex form. What I have instead is standard form. So what can I figure out from standard form? Well, I can figure out which way it opens. 5, positive, opens up. I could also figure out how many zeros it has by doing my discriminant. So let's try it. Negative 2 squared minus 4 times 5 times 4. That gets me a negative 76. So I know I have no zeros. These two things combined, the fact that it opens up and has no zeros, can tell me that my picture has to look something like this. It has to open up, it can't have zeros. And what does that tell us about the vertex? No matter what, it has to be above the x-axis. I don't care what the vertex is. I could go calculate if I really wanted to. I just want to use some thinking, some problem solving. Okay, let's look at the next one. The height of a trampoline jumper in meters can be modeled by this equation, where t is the time in seconds. How many times will the jumper pass through a height of 6 meters? So, look at my equation, I can tell it opens down, which kind of makes sense. So the trampoline goes up, comes back down. I want to know how many times it passed through 6. So some options. Maybe 6 is here, and it passed through twice. Maybe 6 is here, and they just barely touched 6. Or maybe 6 is up there, and they never actually hit 6. So basically I'm asking, can this be solved or not? If I put 6 in for my height, and I solve or rearrange to solve for t, I don't actually care what the solutions are, I just care if it can be solved. And to solve things, usually we put them in the correct order, so standard form, and we make them equal to 0 before we start. If we bring the 6 over to the right side, bring it this way, we'll end up with 4.003. That would be the quadratic we would need to solve to figure out when they hit 6. I just care if they hit 6. So let's find our discriminant. 9.17 squared, 4ac. Put it all in, see what happens. I get 181.76. What does that tell me? It's positive. There are 2 solutions. Therefore, they pass through 6 meters twice. Again, I didn't solve and figure out where they hit 6 meters. We've done it before when we solve quadratics. I just care if they hit 6 meters. In this case, we figured it out twice. That's one way. You could also figure out the vertex if you wanted to. Negative b over 2a, plug it in, figure your vertex. Our vertex is higher than 6. Well, we got to pass through 6 twice. That's the second way. I'm just trying to get our brains thinking here. Okay, last one. For what value of k will this function have no zeros, 1 0, or 2 zeros? So it's using the idea of discriminant again. We know that it has no zeros if our discriminant is less than 0. We know it has 1 0 if our discriminant equals 0. And we know we have 2 zeros if our discriminant is greater than 0. Let's find our discriminant. B squared minus 4 times a, which in this case is k, c. I need to solve this. 10 squared is 100. 4 times k times 9 is 36k. If I don't want to solve this, I can treat the less than sign as an equal sign. Okay. Numbers on one side, others on the other, and I end up with 100 over 36. So as long as k is greater than whatever 100 over 36 is, you can change it to a decimal if you want to. What's 5 thirds, 1.666. As long as it's bigger than that, or sorry, 2.666, then you're going to get no zeros. You could try what you want. Let's try k is 5. What would happen? Well, I get 100 minus 36 times 5. That's a negative. That won't work. If I want to figure out 1 0, it's the same equation. 10 squared minus 4 times k times 9. But it equals 0. Well, this looks exactly the same. Except now I actually do have the equal sign. So this time, if k is exactly 100 over 36, or 5 thirds, or 1.6, or say 2.66666, then you'll end up with only 1 0. And obviously the last situation, I can skip the math. I know what's going to happen here. If k is less than 100 over 36, well, then we got the 2 0 situation. Okay, so the idea here is that we can use inequalities as equal signs. Kind of going to domain and range. We can solve them in a variety of situations. All right, that's our idea for today. Nature of roots. I don't actually care what solutions are. I care if they can be solved. There's more than one way of approaching these things, but take a look at the information you're given, what forms you're given, what would make the most sense in each situation.